One day, one of my junior came to me and asked, "Sir, can you quickly tell me how I can become a data engineer, how I can get into a data engineering career, and how much time it will take? Can you just tell me quickly?" And I paused for a while and I asked him a question. I said, "It depends on what you want to have and how you want to have it." And then he got confused. "Sir, I just need to know how much time it will take and what I need to do. That's it." Again, I said, "It depends on what you need, how you need it, and by when. So it depends." So he said, "Sir, can you please clarify?" I said, "Okay, let's take an example. If you're hungry, you can either fulfill yourself by making a Maggie. How much time do you think you will take to make a Maggie?" He said, "Sir, 2 minutes. I'll just pour some water, put the noodles, and I'll have it." I said, "Yes, very good. But will it be fulfilling?" "Well, yeah, it will. It will quench my hunger, and I think that should be fine." But I asked him, "What if you want to have it with vegetables and some healthy stuff into it and make it a bit more fulfilling?" He said, "Then, sir, that might take more than 2 minutes. It might take 5 minutes or 7 minutes because I have to chop the vegetables and do it everything." I said, "Well, very good. Now take it to the next level. What if you want to, instead of having Maggi noodles, you want to have Hakka noodles or a Chinese noodles?" He said that, "Sir, that's quite a big and complex recipe. It will take me at least 10-15 minutes." I said, "That is my answer. You want to become a data engineer, okay? Depends on what kind of data engineer you want to become. Because there is a path for 2-minute Maggie, there's a path for a 5-minute Maggie with vegetables, and then there is a path for a good Chinese Hakka noodles, which will take you 15 minutes. He got my answer. He said, "Sir, I would go for Hakka noodles, or bare minimum at least Maggie with vegetables." I said, "Yes, now sit and I'll tell you how to do it." So yeah, jokes apart, guys, this roadmap which I'm going to talk about is something which I have prepared after doing a lot of research, adding my experience. And this, I have broken it out in 5 phases: phase 1, phase 2, phase 3, phase 4, phase 5. Now, I could have also done it from the time frame perspective, but I leave this to you because a lot of things which I have shared here is almost everything I think is needed for you to become a successful data engineer until you get your job. And it really depends on what kind of roadmap you want to have. You can shrink it, you can expand it based on your requirements, your needs, your readiness already, if you are already coming from a background in data. So it all depends. So it's very difficult to put a time frame into it, but I have broken it into phases, and you are the best judge how much time you think you're gonna take. But I'm pretty sure that if you watch this video till the very end, the details and the resources which I have brought, most of those resources are free resources, and if you can put your efforts into it, I'm damn confident that you will be quite ready as far as fetching a job in data engineering is concerned. But because it is such an extensive whiteboarding exercise, I could have not done it on this whiteboard. So we'll go to my computer screen, and I have created a mind map, and we'll explore this mind map step by step. And I think by that you will understand a lot about what I think you should do step by step. So let's go to the computer screen and see how we should approach this whole data engineering career roadmap. So friends, first of all, let's understand who is a data engineer. So as you can see in this image, a data engineer is someone who will build, develop, design, and then finally maintain the data pipelines, the ETL, ELT pipelines, from which the data will be collected, processed, and stored into your data lakes, data warehouses, or data lake houses. And who would be the consumer of this? It would be the data analysts, the data scientists, the business users, all those people. So data engineers, you are the backbone on top of which this whole data platform will stand. This particular video or this particular roadmap is for everyone. It is for a beginner, a career switcher, or a recent graduate. So you might be coming from a non-technical background with no IT experience, or you're already in IT but trying to get into data engineering. There could be other people as well, other groups of people and graduates or professionals who wants to learn this, because I have tried doing it in a way where it is very detailed. Detailed means that I have actually pasted actual links of resources from where you can go and start studying right now. Okay. I will show you the links, but if you want to directly get the access to the links, I'll create a document of this whole roadmap, and then I'll put it into our video comments
and descriptions, and you can download it from there. So yeah, let's start. Let's start with this whole journey of becoming a data engineer. And yeah, so this is how we will be going. So let me just zoom out a bit. So these are the 5 phases we are talking about. So let's first, and in between we'll also have some bonus tips. And these bonus tips are actually the harsh truths and misconceptions which we have while building a career, okay? And specific to data engineering. So let's start with phase one. What is phase one? Let's zoom in. So what is phase one? The phase one is building a strong foundation, guys. Because if you don't have a strong foundation, there's no point of building a career, because data is a very different from traditional IT systems. You need to know a bit of fundamentals here, okay? Okay, so these are the foundations on which you have to start. The number one is the SQL, because without SQL knowledge, it will be very difficult for you to start your journey. You have to understand the basics. What is an inner join? What is a left outer? What is a right outer? What kind of aggregations, group by, count, sum, how we use subqueries, how we use common table expressions, basic DDL, DML, insert, update, delete, basic database normalization techniques, okay? So all that you can learn, and for everything I have also given you the resources, okay? So you can go to mode analytics tutorial, SQL tutorial, then there is lead code. Okay, let's go to SQL zoo for once, okay? So see, these are all the examples which you can go through and start learning. Coming back to our board, this is your first foundation which you have to cater to. Now the second one is Linux, because all these data pipelines will be based on cloud, and you would be using Linux some way or the other. So that's why you need to know the basic file systems, basic file manipulation, permission. And tell me guys, I will be more than happy to create a dedicated tutorial series on Linux. If that is something which you look forward to, I can try do that for you. But if you want to learn Linux, then there is Linux Journey, Ryan's tutorial, Code Cloud. This is a paid one, but if I have to go here, and by the way, I have just searched all this online and looked for some reviews and gave you this, okay? It's not an exhaustive list. If you Google, you might end up finding better resources. But if I click on this one, so this is how you can learn. Command line, all these kind of so let's go to command line. So see, touch command is used to create a file, and you can actually practice it, I guess. Here I have not used this much, but yes, it's a great tool. Okay, so coming back to so Linux, very important. Then databases. Obviously, you are becoming a data engineer. How you can do it without a database knowledge? So Khan Academy has a very good section on SQL, which I liked. If I click on that, I can show you as well. So basically here you have all the SQL basics. Welcome to SQL, creating and inserting a table, querying the table, all those kind of things are there. So you can start and you can see from where you need to start, because a lot of you might already have all these basics. So you can simply go to another section, okay, another phase or another section of this roadmap. It is not that you have to start from phase one. You might be already at phase two, but I am considering everyone on this journey. Git is very important, guys, because now with DevOps and with data ops, everything, you have version control and everything. See, initially data was not a integral part of agile development and DevSecOps frameworks. But now even data is moving into data operations, and all of the version control is moving, and you need to understand Git because you will be programming a lot. So gone are the days when you used to just write your SQL queries. Now you would be checking in, checking out your code. It could be SQL, it could be Java, it could be Python. So you need to know this. It is not a rocket science. You just have to spend some time. But I found this tutorial, Atlassian tutorial, very interesting. So it actually gives you all the good things, setting up your repository, what is Git, how to install Git. Okay, so I think it's a very good option. How we can use branches. So I think, for example, if I go to saving changes, okay, now it will explain you what kind of commands, what is git add, how it works. See, very nicely it has explained everything. So you can actually use what is git clone. If I have to go to git clone, it will help you understand what is git cloning. So we both have a working copy, okay, and then we both can commit changes, but make sure that this particular copy which we have at the central SVN repo has the latest one. All those kind of concepts you need to understand, but it's not rocket science. You can learn it very easily. And last but definitely not the least is Python, because now everything is becoming Python based and you need to understand Python. You need to understand data types, control flow, functions, basic Python, OOPS concepts, libraries like pandas, numpy, all these, all these libraries you need to understand. I think one thing which I love is this book, which is Automate Boring Stuff with Python. This book is a very good book if you want to get practical programming experience using interesting stuff. Okay. For example, web scraping. What is web scraping? In web scraping, we go to web and scrap the data. Okay. So it will show you how you can do it. It's a very interesting book to have. It is a free source. Okay. So you can always come to this source. And similarly, we have Code Academy, Data Camp. So if I have to go Data Camp, you can start. See, I cannot show you everything, but I will put the links, as I said, if you want, in the comment section, any comment, and that will like, I want this, something like that. And then definitely if there are a lot of comments, I will attach it, making it a PDF kind of a document, and I'll attach it in the comments and in the description. So now, as we are here, let's come to our first bonus tip. Okay, what is our bonus tip? It is not a tip actually. Let me just remove the curtains. It is actually a harsh truth, which is that a lot of data engineering isn't glamorous. It involves cleaning messy data, troubleshooting failing pipelines at 2 a.m., dealing with legacy systems, optimizing queries that run too slowly. It requires patience and meticulous attention to detail. So don't think that it's a hunky-dory kind of a story. You need to put in your hard work, and yeah, data engineers are some of the most hardworking guys working behind the scenes. So it's not, but yeah, if you can do the heavy lifting, it will pay you handsomely. It will actually be one of the most stable careers. Take my words, guys. All are concerned about what will happen. AI is coming and all. Regardless of what is coming, one thing which will be the epitome of truth, a universal truth based on my understanding, is the very fact that you will always need data. You will always need data from diverse sources. You will always need people to build and maintain and monitor those pipelines in production. So data engineers are not going anywhere. In fact, we will have more and more demand coming for data engineering. Another misconception we have is you don't need to be a genius coder. Okay, generally what happens, don't get confused. Maybe the way I have written it is slightly confusing, but the misconception is that you have to be a fabulous coder or a PhD statistician to get into data. No, you just need decent programming skills. You need strong SQL, because that will help you a lot. Logical thinking, analytical thinking, understanding of systems, how systems connect, how data flows from one system to another. So it is more engineering than science. And if you are an engineer, you will understand it is like connecting the dots. So don't think that you are going into a field which is very tough. Yes, it is difficult, but it is not impossible for a beginner to get into this. Okay, so that's one of the misconceptions I want to break. So I think with that said, we should be done with our phase one, which is building solid foundation. Okay, building solid foundation, but foundation is just the tip of the iceberg. The actual thing comes in phase 2. Now we'll understand what is phase 2. So in phase 2, let me just zoom in a bit, and guys, give me your comments. Are you liking me explaining it in here? Because see, in whiteboard it takes me a lot of time, guys, to draw things, and then there is a limitation of space, guys, and that's why I thought maybe let me try doing it this way. Yes, it is not that engaging, I know, because yeah, obviously whiteboard is bigger and then we can talk better there, I think, but this is also educational, guys. I think if you like it, it will be much more informative here. Okay, so phase 2, the phase 2 is core data engineering concepts and tool. Now we have understood the fundamentals. Now the second phase is core data engineering and tools. So what we have here, we have data modeling and data warehousing concepts. You have to understand what is star schema, what is snowflake schema, what is Kimball methodology, who was Ralph Kimball, go into the history of that. Then there is this Bible, which in the data industry, we call this book as the Bible of everything, which is the Data Warehouse Toolkit by Ralph Kimball. It is a classic. And a lot of things which came later was based on this. Is it 100% mandatory? No. But do you want a Maggie? or a Hakka noodle, again we go back to the same discussion. So all of these things you don't have to do at once, okay? Take it one by one, slowly, gradually, pick this up, pick that up, try to build and try to go in a manner which is easier to you. Some might finish the fundamentals in 1 month, some might take 3 months, but you have to set a deadline, okay? You have to set a deadline. Although I said I will not put some time frames around it, but still, at the end of this video, if you stick around, we will definitely talk about what I think should be, a realistic timeline for this for multiple kind of people. So yeah, data warehousing, normalization, denormalization, all this. You don't have to get into the book. You can find it on Google. You have to be good at ETL, ELT, extract, transform, load and extract, load and transform. Both concepts are very important to understand. You need to understand how we can do it. Now with Python, you need to understand how you can do these kind of ETL pipelines using Panda. Okay. A very good resource I found was this website here. Let me just show you this. So ETL tutorial, get started with ETL. A very nice looking website with all the data here. Okay. It will clear a lot of fundamentals for you. You can read this out and then you can do your further exploration. But yeah, do make that clear. Data warehouse concepts again is very important, guys. Purpose, what is your purpose architecture? You need to understand what is Redshift, what is Snowflake. Okay. Okay, now it is coming on my way to let me just remove this myth first. Okay, now let's remove it. Then I think it will be better. So misconception number 2, you don't need to master the entire Hadoop ecosystem. Focus on Spark and understand the concepts behind the older tools. Focus deeply on one cloud provider initially. Okay, so now this is a misconception. You will come to know where exactly it applies. Okay, right now don't focus on that. It was obstructing my way, so that's why I have cleared it. But keep it within your head. Purpose architecture, Redshift, BigQuery, Snowflake. You have to pick any one, okay, and see how you can use it. How you have to understand the difference between OLTP, which is online transactional processing, versus OLAP, which is online analytical processing. OLAP is all about what we do in the data warehousing things. I have talked in depth about it in my previous data lake videos, database videos. So go check that out. Here comes what the misconception we are talking about. Introduction to big data technology. Conceptual understanding we have to build. Okay, we have to understand what problems do Hadoop, SDFS, MapReduce, okay, solve at the first place, okay, and why it has become foundational technologies for something like Spark, Apache Spark. We have Spark SQL, we have Hive SQL on Hadoop, Presto, Trino. All these kind of technologies are booming to support big data processing. Okay, so this all supports big data processing. Okay, so yeah, that's something which you have to focus on. So that is where the misconception lies, that you don't need to master the entire Hadoop ecosystem. You just need to know the basics of Hadoop. Okay, don't go like I have to master everything. Now you have Spark, which is a very good abstraction layer on top of Hadoop. Everything is now baked into Apache Spark, and it is a lot more easier. On top of Apache Spark, we now have Databricks. I've recently made a video on Databricks. I might link it here. So just to give you some background here. So first came Hadoop file system. Okay, Hadoop and MapReduce, we can say. On top of that, we built Apache Spark. And now on Apache Spark, we have Databricks. Okay. So now every big data processing, anything to do with AI ML use cases, we are preferring Databricks. So now coming back to our other areas which we have to do as part of our core fundamental. Now comes the cloud. Okay. So basically, so you have to understand the core services of all the cloud platforms, but initially choose any one. And because I get certain opportunities to promote my course, so I'm promoting it here, which is AWS for beginners course, which I built, and which has been really helpful for people who know nothing about cloud computing and AWS. We have covered more than 14-15 hours of content here. So if I have to show you, this is this is what you will get here. There's a lot we are covering. Okay, there's a lot we are covering here. Everything from the basics we have hands-on exercises, everything. And very soon you will have a new module getting added here, and that is related to how we can leverage generative AI. Very interesting and powerful module where I will be showing you how you can top notch your game in cloud using generative AI, how I do it. Okay, so yeah, plug from my side, a marketing plug, but yeah, there are better, much better courses there could be. So I'm not saying that this is the best, but yes, you can explore it. And if you feel that this is something which you like, and if you like the way I teach, then definitely check this course out. I'll put this in the description links and comments. So now cloud done, and now important is workflow orchestration, because now with all these data pipelines coming up, so let me tell you a history. So basically, so when I started my journey, okay, what were the ETL platforms? It were traditional full 3-tier thick client ETL platforms like Informatica, which is still very relevant today. Then we had data stage, okay, we had SAP data services. All these provided you with monitoring capabilities where you could monitor the jobs. But now what we have done is we have moved from here to Python, and we are building it using open libraries like Panda or NumPy. I'm just giving examples, guys. Okay, now you have to orchestrate these pipelines, right? And for that, Apache Airflow has become really popular, and you can learn a lot about Apache Airflow from this website here. So let me just, so Apache Airflow, you can go to the documentation here. Okay, there's a lot we can do with Apache Airflow, guys. See here, Databricks. If I see, it will give you the connectors, how to connect with Databricks and everything. MySQL, it has connectors with everyone. So Apache Hive, Apache HDFS, Apache Spark, Google. So yeah, just explore. It is basically your, your monitoring tool. Like you can have your DAGs. So directed acyclic graph. I forgot. I actually made a video, I guess, on this, but I forgot. So let's open this. So DAG is a core concept of Airflow, collecting tasks together, organized with dependencies and relationships to say how they should run. So this is how you will have, okay, you will have all these connected processes, 4 tasks A, B, C, D, and dictates the order in which it has to run. So this will run first. And by the way, all this was possible when you were using traditional ETL tools, but in here you can do a lot more. Okay. So this is where DAGs comes into picture, and Apache Airflow is your orchestration platform for your data pipeline. So just to simplify things and not to go to too much detail, Apache Airflow is your orchestration platform, workflow orchestration platform. Okay. So now with all this, you are done with phase 2, which is core data engineering. Okay. Now let's go to phase 3. Okay. What is phase 3? Phase 3 is building and specializing. Now with this much knowledge which you have got, you should have a fair understanding of how to build things up. Okay, so now from this stage, you will be starting to build things. So number 1, data specialization on cloud. Okay, now what you're trying to focus is you are done with your fundamentals, you are done with your cloud foundations and everything. Now you are starting to focus on technologies which are very specific to data. So AWS, we have Glue, Redshift, Kinesis. You have to understand. Pick anyone for the starting bit, but then you have to master these things. Like in GCP, you need to know how data flow works, Dataproc, PubSub. In Azure, you have Azure Data Factory, Synapse Analytics. You have Databricks managed Spark environment under Azure. All that you have to understand. So I have tried. I will not give you the resources for it because there's so much. So you have to just explore, go on Udemy, go on Coursera, and you will find a lot of courses and a lot of free material on YouTube as well. Then comes containerization, guys. So containerization has become very important because right now we are in a world of event-driven architectures, okay, and we are in microservices architecture. So basically, just to give you a brief about it, so basically instead of having one particular monolith environment, okay, which had your front end connected to your application and then connecting to your database, everything in one monolith, it has now moved to small microservices, okay, and this could be your API interface which will be connecting to these separately, and then it will have its own databases here. Okay, and these microservices could be interacting with each other as well through this API interface, API gateway, whatever. This could be your sales microservices, this could be your finance microservices, manufacturing, whatever. I'm just giving a random example, and this could be your HR. So you have to understand what Docker does is Docker actually uses a Docker file and then creates a container image. and that container image will have all the data about your application, which can then be deployed on Kubernetes, for orchestration and everything. So you can go into the detail of it. It is a world on its own. But yeah, you can go and you can use these documentations. There's a very good course by Nigel Poulton, which you can search. It is, I think, on Udemy. You can search for it. And then things like this, where we have labs, playwithdocker.com. Okay, so these will help you to understand Docker concepts easily, but there's plethora of documentation around Docker. Infrastructure as a code is also good, optional, but good to know as a data engineer. It is basically very important for a cloud engineer, but for you it's optional. But basically now you have products like Terraform, which is infrastructure as code. So for building your infrastructure, you will have your own code which can be deployed. For example, previously when you used to deploy any VM, for example, that VM used to be manually configured. Now what you will do, you will write your code, okay, and that piece of code can deploy a VM with all the same configuration on GCP, on AWS, and on Azure at once. So you understand how easy it becomes to maintain the infrastructure. It is really good. So yeah, this is something which you should be focusing on. Again, there's a lot of documentation around it, but it is optional for data engineers, but good to have. Eventually you have to learn it, so better to do it now. So yeah, so this brings us to the another one, which is data streaming. Now I would not, like, initially I thought it's optional, but now I'm thinking you should better do it. Okay, you should learn a bit about the consumer, producer, broker concepts, how Kafka, Kinesis, PubSub, all these are data streaming platforms which will help you fetch the data in real time. And for that, I think there's a very good book, and that book is Kafka the Definite Guide. A very good book if you want to read, if you love reading. I think this is something which you should definitely consider. I have also made a very good useful video on Kafka where I have explained what does it mean to be in a PubSub architecture. Okay, now is the time for a bonus tip. What's the bonus tip? Okay, I think this also a good resource I found. Developer Confident. Okay, what do Kafka? See, this is how Kafka works. It is right in the middle of everything. Okay, you can consider it as a as an airport. You have this belt where you keep your luggage, and it keeps on rotating, and whenever you are there, you pick it up. Okay, that's a very good real life analogy. You watch my video, I've explained it to a very good detail. This is Kafka. And now coming to the harsh truth, certificates without projects are almost worthless. Your GitHub portfolio is your proof of skill. Getting the first job is often the biggest hurdle. Okay, networking starts now. All this which I am talking will make sense in some time. I just removed this bonus tip. So basically what we are trying here is, we are not rushing for certifications, guys, because it won't help you anyways, because if you're not building your foundations correctly, it's not going to help you. So the last bit, actually I should have opened it after this one, but okay, let it be. So this is your first step. Now in this stage, you have to first go to GitHub, create your GitHub account, and then you have to focus on building 2 to 3 end-to-end projects showcasing your skills. Use your chosen cloud provider. There could be something like this. You can create an ETL pipeline, ingest data from a public API like weather or stocks. It is public API, so the data can be read. Then you clean, transform the data, prepare a business use case, think about what you can do, create those kind of data pipelines. You have to think about those use cases. You can use ChatGPT and and others, Gemini, for your help. You can simply go and ask them that I want to create this project, help me out with that. But yeah, you should do this, because this is what will differentiate you from someone who has just mugged up few definitions and not done it on the ground, because we don't have real hand experience yet. So we have to do the heavy lifting of doing it ourselves. You can create a simple streaming project as well, connecting to Kafka, getting a real-time data. There are different providers who can help you with IoT kind of a data. You can generate dummy data, I guess, and stream it using Kafka. Data warehouse, design a star schema for a sample data set, load data, write analytical queries. So you have to understand, you should have a better understanding of what is a star schema. You should be understanding that you have a fact table, okay, which is a fact table connecting to dimension tables, okay, like these are your dimension tables, and in the center you have your fact table. Okay, So this is called as star schema. There's a lot of detail in this, but yeah, you can have a basic understanding of what it is. And guys, please don't feel overwhelmed. Hello, are you still there? Don't feel overwhelmed. All this which I'm telling you, I have done extensive research, but I'm not saying that you have to tick all the boxes. This is just a path. You have to decide, you have to select. What I'm saying is, even if you can touch this path 70%, I guarantee you that you will be standing in the top 5%, 10% people applying for data engineering jobs. Okay. So don't get overwhelmed. It is a journey. We'll talk about the timelines. Anything I told you, it should not be a Maggie. It has to be a very good noodles, Chinese noodles. Okay. So don't worry. We'll crack this together. Don't worry. So now we are done and we are now coming to phase 4. Just to summarize, we have built our foundation, then we went into cloud data engineering and tools what we need in phase 2. In phase 3 we are now building a specialization based on the knowledge we have built. Some good projects on GitHub we need to build. Now phase 4 is all about jobs. Okay, all about jobs, and let's see how we should approach it. So number 1 is resume building. What we should do here? So we should tailor our resume to data engineering roles. It's a very common advice to tailor your resume based on the jobs you're applying. Highlighting project skills, Python, SQL, CloudFront, Spark, Airflow, Docker, etc., and any relevant certifications. Okay. Now here the certifications will come in handy, but we'll not touch certifications as of now. Okay. Then once you have done the resume building, there is a very good website, by the way. You can use this website, resume.io. I always recommend this to everyone. So it has very fantastic templates to be used. You have to understand which is a very good professional for Indian context. Okay, don't make, generally we have CVs with our photos here. Okay, generally it's not taken well. Don't put photos in your CV. Your plain CV with enough information should be okay. Now coming to interview preparation. So now for that you have to practice medium to hard lead code, hacker rank problems, be ready for complex joins. So you have to go to lead code. It is a very famous website, lead code, where you can solve critical problems. You have to practice Python. You have to also understand basic system design, like basic data pipeline design. How would you design a system to ingest X data and make it available for Y analysis? So X is your data, Y is your analysis. Now as a data engineer, you have to explain how you will ingest that data, how you will store that data, what has to be kept and what can be neglected. All those kind of things and skills will come into picture. So I think we can please search lead code. So it's a very good website, and you can you can explore this. You can explore the problems and you can explore different areas, whatever you want. Okay, so very good website. Now for networking, you have to use LinkedIn to connect to connect to recruiters. You can send them cold emails to talent management team or HR team stating your experience and what you're looking for. You can also connect to people who always post about new openings and new jobs. Reach out. There's no harm in reaching out and connecting to people. Do your networking, connect to people who know more about this, join communities which will help you. And then you start applying. Apply widely but tailor applications. Don't be discouraged by rejection. I also get rejected. What do you think? I get selected? Nobody gets selected in your first attempt. Even after 18 years of experience, I get rejected. There's nothing bad. It's just that that particular role and your knowledge does not fit at this point of time. It's as simple as that. So don't get disheartened. Rejections are good. It tells you where you are lacking as far as you're doing your analysis. Face interviews. Not many people face interviews regularly, including me. So that's an improvement which we have to make. We have to face interviews regularly. I am quite settled in my current profile, but whenever I have to think about a job change, for example, I have to face interviews. That's the harsh reality of it, and get rejected and be ready to get rejected. And when you are not able to crack data engineering, be open and flexible to try other roles, guys. What is there? So data engineering you can't, for example, go for, then go for data analyst. Data scientist is very tough. Okay, we are not considering right now. So data engineers can very easily apply for data analysts. Slight changes, but yeah, you should. You should. And then analytics engineer, you can also understand Power BI, Tableau. That will help you understand how dashboards work. Okay, you could be a very good, if you are a creative person, you could excel in a dashboard kind of a profile, dashboard expert or dashboard developer. One thing which I forgot was this. Sorry, I forgot to talk about this. So it would be a behavioral kind of interview where you would be asked to, a scenario based question, and you should always try to explain using STAR method, which is situation, task, action, result. So the question would be, tell me a time where you were faced a very difficult situation as a data engineer and how you resolved it. So that's where you have to build the situation. So the situation could be that during one of the year-end activities, one of the pipeline was not running successfully and it was causing a huge business damage. Then what task we performed? We started troubleshooting this. Then these are the actions which we took, which resulted in we fixing the problem, and these were our lesson learned. So that's kind of STAR framework you should go for. So yeah, now this is job hunting, and hopefully by this time we should be able to land a job, and with some guidance and some luck and some blessings from the god, we will definitely find something. Okay, then here at this point we are in phase 5, and phase 5 is all about continuous learning, which is a career long thing, and that is about staying updated. Follow data engineering blogs, Netflix, Uber, read these case studies. Data is ever changing, so you have to be updated about new tools and technologies. Here comes the certification bit, guys. Here comes the certification bit. Now is the time to get certified. Now you deserve to be certified because you have done the heavy lifting. Now you can say that yes, I am a certified data engineer. I think the most respected of these are this GCP professional data engineer, because Google has a command on data. Okay, so yeah, I think that would be really good, but others are as well you can do. And then you have Databricks and Snowflake for specific vendor specific certifications. Always keep on contributing to open source. It looks great. Highlight your achievements in your GitHub, on your LinkedIn post, and yeah, you have to continuously evolve. So that is something which is there. And again, time for a bonus tip, and this bonus tip says you might start as a junior data engineer or in a role that blends analysis and engineering. Take it. The initial practical experience is invaluable. Don't get fixated on the name of the role. As far as you are trying to get into data industry, take any role which gives you that exposure, because once you are within the company, within the industry, you will start understanding how things work on the ground. So practical experience, as quickly as you can get, you should enter. So title does not matter. What really matters is you're constantly learning and building on your skills. Okay. So it could be that you get a job as a data analyst and you are only supposed to use Microsoft Excel. What's bad in that? I have seen some of the best data analysis done on Excel with some best minds. What's bad in that? Don't play the ego game. Don't play the ego game, guys. Okay, be humble. Whatever opportunity we are getting, we should be ready to embrace those opportunities. So yeah, guys, these are the 5 phases. Now coming to the timelines. Okay, so timelines wise, it's very tricky, guys. To be honest, timeline wise, it is very tricky, because what should I say? What do you think? So consider that the phase 1, the fundamentals can take somewhere around, because fundamentals are very important, you can take 1 to 2 months in phase 1. Phase 2 again is very crucial, so 1 to 2 months, I would say 1 to 3 months here. So that's there. And then from phase 3, it could be slightly easier, because initial hurdles will be removed and then you will be more fluent in all these. So we can take 2 months here approximately. And phase 4, for example, is where you are doing the job hunt, so take 1 month, for example, here in phase 4. And phase 5 is continuous, so we'll not consider it. I think 6 to 7 months is good enough time to get in a very good shape. But if you go said, no sir, I will minimum take 12 months, then also it's not bad. We are not playing the short term game, guys. We are doing the heavy lifting and playing the long term game. And who knows, you might land a job here itself. Who knows? You might land a job here itself. So job hunting, I'm not saying that. So again, all these phases which I'm telling you can be, can be changed, can be customized based on your current experience. If you are already working in IT and knows a bit, you can simply skip phase 1, start from phase 2. So it's completely customizable based on your understanding. So now coming to my final thoughts, okay, because this is important, guys. Sometimes we get caught into the nitty gritties, but let me just, number one, be patient and persistent. It is a marathon. It will be frustrating when the code won't work, concepts won't get into your head, but you have to keep pushing. Concepts, focus on concepts. Tools will always change. ETL concepts and ELT concepts and data lake and data warehouse concepts will remain constant. It could be Databricks, it could be Snowflake, it could be Azure, AWS, regardless of where you are doing it. Concepts and the first principles always remain the same. And then build. You have to keep on building new things, because theory won't take you far. Theory will not take you further. So you have to start implementing and building things from your own hand. Projects, showcase your projects, that's the key. And then communicate. You have to be very good in your communication, how to talk to stakeholders, how to gather requirements, how to work with different teams, across board. It could be your support teams, it could be your DevOps teams, your data engineers, your data scientists, all the members. Okay, so it's the key. And with that said, I hope this whole thing will help you, because trust me, guys, nothing is impossible. I'm not giving you any motivational speech here, but I truly feel you can do it. Okay, you can do it. Just give yourself enough time, be patient, keep looking for new opportunities to do hands-on. So hands-on plus build plus keep learning. Okay, and you will be good to go. So guys, I never thought it would be such a big lecture. I don't know what's the time, how long is this video, but I'll still put it. Hopefully it will help you plan your journey ahead. And let me know in the comment if you want this whole guide with links. I will put it in the description and the pinned comment so you can download it. So until next time, thank you so much. Keep learning, keep sharing all your knowledge, and yes, keep hustling. Bye for now.